Hey Rascals. So I'm gonna give you guys a little homework help, actually classwork help, for today's entry task. So what you want to have in front of you is entry task from October 14th. We're gonna do questions 1 and 2 together. 3 is very similar to number 2, so I don't want to waste your time going over 2 of the same type of problem. Okay. So get that out. Make sure you have your notes in front of you, and of course, got to have that calculator, okay? I don't think you actually need your periodic table for this one. All right, so we're gonna focus in on number 1 first, of course. So the amount of cobalt 60 in a sample has decreased from 16 grams to 1 gram in a period of 10.5 years. From this info, calculate the half-life of cobalt 60. I also put our 2 formulas that we're gonna need over here. Now, if you recall in class, I like to go and kind of annotate the question prompt first, just so I know which values for these formulas I know, and that helps me kind of figure out which formula to use to get started, okay? So, the amount of cobalt 60, blah, 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 so 16 grams to 1 gram, so those being gram values, that tells me automatically it's gonna be my MI and my MF, right? So I began with 16 grams, so this is my MI. Ended with 1 gram as my MF value, okay? So I can probably guess right away that I need to use this formula right here because I have 2 of those 3 values. My unknown in this case is the N, at least it's unknown so far, all right? Now, what I also have is this decay right here occurred over a period of 10.5 years, okay? Now, that 1 gram is a lot less than half of 16 grams. So this 10.5 years is not my half-life. This is just my age. So that's my T. All right? So what you guys need to be able to do, right, in this case, is remember what the symbols mean. T, T1 half, and N. So the values I don't know yet are T1 half and N. Right? So those are the values I'm going to have to go through and try to solve for, right? So again, I use my 2 formulas now to figure out which one I can use to solve for one of those 2 values, right? So I want to pick which formula I know the most values in to figure that out. So I only know one of these. All I know is T. I don't know T1 half or N. So I can't use this formula yet, okay? Here I know both MI and MF, right? The only thing I don't know yet is N. Right, so that tells me I'm going to use this formula to start. I'm going to find N, right? But what am I actually trying to find? The half-life. But once I know N, I plug it into this formula, right? Because I already know T. So then once I know T and N, then I can solve for my half-life for T1 half. Okay? So this is why your calculators are important, because I'm challenging you guys a little bit on these entry task questions because none of them come out to an entire half-life. Okay, so we're in between half-lives, so we're going to have to use formulas. Actually, number 1 does come out to a whole one. I'm sorry about that. Anyways, so we're ready to get started. So I want to use my MI times 0.5 to the N equals MF. I'm just going to rewrite my formula. And I'm going to substitute the actual values in for the symbols, the ones I know. I know MI is 16. And I know MF is 1. All right, let's put some units in there. So what this tells me is 16 times 0.5 to the N power is going to give me a final answer of 1 gram there, okay? So what I do in algebra first, right, is I'm going to take whatever I can combine from both sides of the equation to try to simplify a little bit, okay? And so what I'll do next here is this 16, I can divide both sides by 16, right, to simplify that. So I'm going to go over 16, I get rid of the 16 on that side, over 16 grams. And what I get is 0.5 to the N power equals 0.0625. All right. Now, this is where we might be doing something new for some of you guys, is solving for that unknown exponent. Okay, so essentially what I'm going to do there is I'm going to use my little LN button. So that's that button on my calculator. You guys got to know where that LN button is on yours. If you don't have a natural log button on your calculator, you'll have to borrow from somebody, I guess, or try to get a new calculator. Spend an extra $10 or something, okay? But the way I was taught to solve for unknown exponents is using that natural log button, okay? And it looks like this. I'm going to take this n, I'm going to bring it down so that I can treat it just like something I would multiply and divide by, right? So my next step here, I'm going to go n 0.5. Now, in order to do that, though, I have to do this weird little thing to my number, and I have to take its natural log. Okay, so that's n natural log of 0.5. Now, because I did a natural log to this side of my equation, I'm going to have to also do it to this side. Okay, now again, that natural log is just simply a button on your calculator, right? You don't really even have to know exactly what it means. To be honest, I don't really know exactly what it means. Ask your math teacher, okay? I just know this is how I can solve for my unknown exponent. So in my chemistry world, it lets me get to the number I want, so I don't really care what the natural log means, okay? Anyways, so I'm at this point. Now, n is my unknown variable. What I can do is I can treat my natural log of 0.5 like I did the 16 over here. I'm going to divide both sides by the natural log of 0.5. I'm going to go over, right? That cancels out. My natural log is 0.5 on that side, right? So now I just push some buttons on my calculator and I will get my value for n. So n equals, right? And then again, it's pretty simple. Turn on my calculator, I'm going to hit ln 0.0625, enter, divided by ln 0.5, and I get 4. N equals 4. Now, what does n tell me? In this case, that tells me that my 16, my initial amount, was cut in half 4 times. 1, 2, 3, 4. So 16 divided by 2 is 8. There's 1. Divided by 2 is 4. 2 divided by 2 is 2. There's 3. 2 divided by 2 is 1. There's my 4th time cut it in half. So I've just gone through 4 half-life periods. Okay? So I now know n, right? What other values do I know? I know t, right? So I now know that n is 4, so I can substitute that 4 into this top equation right there, right? So I'm going to take this value, 4, and substitute it in. I know t is 10.5. Okay, equals t 1/2, that's the value I don't know yet, times 4. All right, then we just divide both sides by 4, right? 10.5 divided by 4, and I should get 2.625 years equals t 1/2. All right, now again, this being chemistry, and we have rules for how we round, right? We don't have quite that degree of certainty, right? So we're going to round that actually to 1 sig fig, right? Because I have 1 sig fig there. So I'm going to just round this to approximately 3 years, right? If I had more precise measurements, I could probably get that number more precisely. All right, so again, if you get to this point right here, I'm really happy that you've done all the kind of the difficult part. Right? Don't stress out too much about sig figs, but if you want to get a perfect score on your quizzes and tests, you also need to round to that correct number of sig figs. Okay? All right, so we'll do number 2, and then we'll shut her down. All right, so numero dos. We are going to do a slightly different type of problem, okay? So again, I'm going to go ahead and write my formulas. T equals t 1/2 times n, and mi times 0.5 n equals mf. All right? Now, with that being said, so remember, t is our age. T1/2 is our half-life time, N is the number of half-life periods. MI is our original amount, 0.5 to the N, and still the number of half-life periods. And MF is our final amount. So this is how much we start with, this is how much we end with. Now the amounts can be grams, it can be percents, it can be atoms, or whatever other measurement we use to talk about how much of the radioisotope we have. However much we start with is MI, however much we end with is MF, okay? So in this question, iodine-131 is used in the medical field for thyroid scans. The half-life of iodine-131 is 8.02 days, right? So what value did they give me this time? This is my T1/2. All right, so my T1/2 is at 8.02 days, okay? Now, how long is required for levels of iodine-131 to decay to 1% of their original amount? Okay, so this is my MF. I want to figure out how long it's going to take me to get to 1% of my original amount. Now, with this one, right, I don't outright tell you what that MI is, all right? But if it's a percent problem, we have to assume that our original percent is 100%. So MI, right? We had all of that amount, whatever we started with, we have 100% of it at our initial time period, right? As soon as that clock starts ticking, though, we start decreasing that by a certain amount over time because that's radioisotope, it's going to decay. All right, so if it's a percent problem, just assume MI, the initial amount, is 100%. Okay, unless for some reason I tell you different, but we'll just assume we have 100% of our original amount when we start, okay? So I know MI and MF again, and I know my half-life, so which equation am I probably going to use first in this case? The one where I know the most values. I know 2 of the 3 variables in this one, so I'm probably going to use that equation first, and then I'll find N, and then substitute N in to get not the half-life this time, but my actual age at the time, all right? So the values I don't know yet are N and T, right? So I know MI, MF, and T1/2. So 2 values I don't know are N and T. I'm going to solve for those, right? So which equation do I start with? I start with the one where I know the most values, and that is the second equation, just like last time. So I'm going to come over here, write out my equation again, MI times 0.5 to the N equals my final amount. All right, what is my MI? 100% times 0.5 to the N equals my final amount, which is 1%. Right? So essentially, I want to figure out how many times I have to cut my original 100% in half to get down to 1%. Now, with this type of problem, though, it's not going to come out to a whole number. All right? If you cut 100 in half over and over, it doesn't come down to a nice even 1. Right? So our N value here won't come out. It'll come out to some sort of number and a decimal. Okay? So we're going to solve that just like we did last time, though. The steps are the same, right? So what am I going to do first? I'm going to divide both sides by 100%. Over 100%. And I get 0.5 to the N equals 0.01. All right? Now, what do I do when I have it under an exponent? Okay, I'm going to go different color here. I bring the N down. Right? 0.5 equals 0.01, right? But when I bring the N and exponent down, I need to plug in this little natural log value right there. Okay? So I've got N times the natural log of 0.5 equals the natural log of 0.01. Right, so that's the step I take. Bring the N down over here, but in order to do that, I have to use this little natural log function. Okay? But if I do it to one side, I gotta do it to the other. That's our algebra rule. Okay? So I've done that. Now I'm going to simplify. Just use algebra. Cross that off over Then I plug those buttons in on my calculator. So natural log of 0.01 divided by natural log of 0.5. Then I get 6.6438, blah, 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 right? I'm gonna go n equals 6.64, right? So now I know my n value, right? But what am I trying to solve for up here in the question? I know n, I also need to solve for t. That's the actual number I'm trying to get to in the first place. I just had to find n first, right? So now that I know n, I can substitute it into that top equation. So I've got the h of that sample is equal to my half-life times n. Do I know my half-life? Yes, it's right here, the 8.02 days, okay? So my second equation then is going to be t equals 8.02 times 6.64. All right, and when I plug that number into my calculator, okay, so 8.02 times 6.64, I get 53.2528, right? So I'm just gonna round that. 53.3 days. There's my number, right? That's the number I wanted to come up with. Now, I rounded it to 53.3 because of the numbers I get. Okay, that should be how I round it. Now, if we go look at our sig figs, right? I've got 8.02, got 100%, 1%. Should I use that 1% as a sig fig? Is that a measurement? Yeah, it's a measurement. So maybe I should actually round this 53.3 to just actually, did we get a perfect score? To just 50, right? I just want one sig fig because that's not a very precise measurement. If it was like 1.00%, I could then go to 3 sig figs. So actually, 50 days would be my golden answer. All right, that's to get a perfect score on your quiz or test. See ya.